I'm going to do a sample problem. It's a strong acid, strong base titration curve, but the reaction is a 1 to 2 mole ratio. And I've got my base, my acid, and I'm going to create a titration curve with at least 5 data points. If I'm given a vague problem like this, I like to kind of set up my curve ahead of time and figure out what points I'm going to use. Since this is starting with a base, I know my initial pH is going to be high, not low, not down here, because its bases have higher pHs. It's strong, so I'm going to have my S curve. I know that the equivalence point right here is going to be at a pH of 7. I don't know what those milliliters are yet, though. So I'm going to start by, so I'm going to calculate my initial pH here. I'm going to get a point here. I usually do halfway here, and then I'm going to do a point over here. This one I know that's the initial, so that's going to have 0 milliliters of the acid added. But let's go ahead and figure out where the equivalence point is. Equivalence point is going to be a Stoich calculation. I'm going to need a balanced chemical equation. So I've got my BaOH2 plus HCl yields BaCl. However, this is a 2 plus, that's a 1 minus, so it's going to be BaCl2. Because you need 2 Cl's to balance out and make that ionic compound neutral overall. Plus H and OH are going to go together and make water. Just easy to write it as HOH when we're dealing with acids and bases. I can tell looking right here that if I have 2 OHs, I'm going to need 2 H's to go with that. And then, but actually you might have started balancing by the fact that there's 2 Cl's, so I need 2 Cl's. And so that should fix it. 1 Ba, 2 OHs, 2 OHs, 2 H's, 2 H's, 2 Cl's, 2 Cl's. So this is why it is a 1 to 2 ratio, and it happens to be 1 of the base to every 2 of the acid. So let's calculate that equivalence point. I've got 25 milliliters of this base, and it's a 0.2 molar. I've got a 0.33 molar solution. I'm trying to figure out how many milliliters that's going to need to neutralize. So I actually have 5 millimoles of the BaOH2, but less, I need to use the 1 to 2 ratio. So it's 1 millimole of BaOH2 to 2 millimoles of HCl. So I have 10 millimoles. I'm going to need this many millimoles of the HCl in order to neutralize it. Molarity equals millimoles over milliliter. So I need to calculate this, I got to switch those, pull the milliliters up, the molarity down. So milliliters is going to be my millimoles divided by my molarity. So I will need 30.3 milliliters of HCl. And at that point, I know that my pH will be 7. So that point right there is 30.3. So I'm going to do halfway between that. So I'll do 15 milliliters and then I'll do 40 milliliters. I just picked one that was after. So let's start with our initial pH when I've added 0 of the acid. What do I have? I only am going to have a strong base. I've got the 0.2 molar BaOH2. It's a strong base, so this is going to fully dissociate, but watch out. I'm going to be making 2 OHs. So the OH minus concentration is actually going to be 2 times the 0.2 or 0.4. So then when I take the negative log of that, that's going to give me the POH. So negative log of 0.4 is going to give me 0.398. But then I have to do 14 minus that. I get a pH of 13.60. Does that make sense? Yep, it's a strong base, 13.6 up there. So now I'm going to do it 15 milliliters. This is where it gets a little bit tricky. I have 0.2 molar, 25 milliliters. I could have written the 5 millimoles since that doesn't change in every problem, but I went ahead and rewrote it. And my acid is the 0.33 molar, and I chose 15 milliliters. 0.33 times 15, I've got 4.95 millimoles. Minus x, so this is going to be the stoic first, minus 2x. See, I need 2 times that. So I need to figure out, after these two react, they're going to make this and make water, but twice as much of those are going to go away. This, however, is a pH neutral salt, so I'm not going to worry about it because it's not going to affect the pH of my final solution. I need twice as much of the HCl. So do I have 5 times 2 is 10. Do I have that much HCl? No, I do not have enough. So this is going to be my limiting. This is going to be all used up, and I'm going to end up having excess of the base. Does that make sense? In my titration curve, I'm at this point, and I'm still in the base region. Yep, because right here we have excess base, equal amounts that cancel each other out, not equal amounts of the actual moles of the H's and the OH's. And then here I'm going to have all excess HCl. So that makes sense. Whichever one's limiting, it's going to have nothing left. I use that to figure out what my x value is. So 4.95 minus 2x equals 0. I'm not going to have any of that left. So I can solve for x. X is going to be the 4.95 divided by 2. So 2.475. That is my x. But I know that 2 times that is 4.95, and we have 0 left here, but this is going to be minus the 2.475. So 5 minus that, I'm going to have an excess of 2.525 millimoles of the BaOH2. I'm going to keep writing the BaOH2 because that 2, I still am going to have to double it. So first, these two reacted, so this is my stoic of those two reacting, and when I'm done, yeah, I have a salt, but it's pH neutral, so I don't care. Water is pH neutral, I don't care. That's all gone, and I have this. So in order to calculate my pH, this is going to determine my pH. However, those are millimoles. What do I need? I need molarity, so 2.525 millimoles divided by 25 plus 15 milliliters total. Remember, you got to add it up because now they're swimming around in more of the solution. So 2.525 divided by the 40 gives me a molarity of 0.0631 molar BaOH2 solution. So when I go to calculate my OH minus concentration, it's going to be 2 times that. 0.12625. So the negative log of that will give me my POH still, since I have excess. And then I have to do 14 minus that to get my pH of 13.10. Does that make sense? I'm right here, so yes, I should still be up there in that region. And remember that those curves generally kind of stay flat. You know, it's not a huge drop at first, and then boom, and then another little bit. So 13.1 there. Yep, it went down a little bit from a little bit more acid added. Okay, this one I know is a pH of 7, so let's do 40. And just like magic, here we go. So I still have my 5 millimoles of my base, and then 13.2 millimoles of my acid. Minus X minus 2X, they're going to react. These guys are pH neutral, so I'm not really worried about how they're going to affect the pH. Minus, do I have 2 times this amount? 5 times 2 is 10, so yes, I've got twice the amount of this. So this case, this is the one that's going to be excess, and that makes sense because I'm past, oops, I lost my graph. I am past the equivalence point, so I should have excess HCl. So minus 5, minus 2 times 5, which is 10. So none of that left. Minus 10, 3.2 millimoles of my HCl left. To calculate the pH, I need to divide it by the total milliliters, which is going to be the 25 plus the 40. So 3.2 divided by 25 plus 40. I got 0.0492 molar HCl. So I don't have to, this is HCl, it's just going to have one of them. pH is just a negative log of that because that is going to equal my H plus concentration. So I get a final pH of 1.31. And that does make sense since now we have excess strong acid. We should be in the strong acid range. So at about 40 milliliters, I'm down at 1.33, and then there's my S curve.